Hello and welcome to part 1 of creating a basic 3D move and dodge game using the Godot Game Engine. My name is Colin. I'm a YouTuber, computer summer camp manager, and a high school computer science and media teacher. And since 2011, I've dedicated this channel to teaching just one piece of software, Blender, for 3D modeling and rigging, 3D animation, creating visual effects for movies, and creating simple code-free video games using Blender's game engine. Again, all of this using just one piece of software, Blender. But you know what? It's time to grow. With the release of Blender 2.8 just around the corner in July of 2019, and I'm most definitely going to be covering that on this channel, so don't worry, it's time to add another piece of software, Godot. If this is your first time hearing of it, it's called the Godot Game Engine. And I've been using Godot for about the last year or so behind the scenes, and if this is your first time hearing of Godot, here's the rundown. Since 2014, Godot has been an open source program, which means, like Blender, it's free and relies and grows on community contributions and public development. Godot is the third fastest growing project on GitHub, the world's largest online development platform, and it's both a 3D and a true 2D game engine. Since Godot 3 was released a little over a year ago, Godot is a modern powerhouse. It uses OpenGL 3, the same graphics library used to create Blender 2.8, and its new real-time render engine, Eevee. Godot is also easy to learn and create games in for the first time. You program your Godot games using either GDScript, Godot's own language based on Python, or in C#, and even if you've never programmed before, it's fairly easy to learn, and I'm going to walk you through it in this series. You can get Godot for yourself at www.godotengine.org, and it's available for Windows, Mac, and Linux. And when you make a game in Godot, you can export it to run and possibly sell on major platforms like Windows, Linux, Mac, Android, and even iOS. There are games out there right now on the major app and game stores made in Godot. Here are a few examples. Got it? Okay, let's jump into game development using the Godot Game Engine. Before we jump in, let's go ahead and check out the project we'll be making in this tutorial mini-series on how to create a basic move and dodge game. We'll be making this game. This game is a simple move and dodge game where you, the player, has to navigate, move, and dodge objects in a 3D environment. You are playing a character that's actually a ball that has to roll around a 3D maze and avoid touching enemies. If you touch an enemy, you'll die and go to the game over screen. You have to collect, this is your goal, collect all of the coins in the maze, and then you win and you go to the you win screen. Okay, this is a simple project that we're going to cover over about 8 or 10 or 12 videos in this tutorial mini-series on how to create this basic move and dodge game, that once you create it step by step, you'll understand how to use Godot and how to make a basic game, and then you can build upon there if you want to make a bigger, better game. I will note that everything you need for this mini-series, in other words, all the 3D models, all the textures, all the sound files, all the images, I'll give you links to those in the description area below each video as you need them in this series. Okay, let's go ahead and jump in, and as you can see, I have it here on my desktop. Godot is not a program that you need to install. There is no installation process. You just download the program for yourself, and here I have it on my desktop, and if you double click on it, there it is, it's opened up, and you can see it opened up a command prompt window on Windows, and I'll just minimize it, and you get Godot's project manager to start. Now I will note that on a Windows computer, it will ask you if Godot is allowed to access the internet, and if you trust it to and you have administrator privileges, yes, you can allow it to access the internet and private networks. It's okay as long as you've gotten Godot from the official website, you're fine. On a Mac, macOS might not trust Godot by default. Because you didn't download the Godot engine from the macOS App Store, you might need to give your computer permission to run a program that's not from an officially recognized developer. I'll put a few screenshots on the screen right now so you know how to enable your Mac computer to run Godot so you can get going for yourself right away. So on the screen right now I have Godot's project manager, which usually has its main area as a list of projects that you've previously created, so you can choose which one you want to open, but by default you don't have any projects, so it gives you this message: you don't currently have any projects. Would you like to explore the official example projects in the asset library? Well, no. We're going to press cancel and we're going to make our own game project right away. To do that, I'm going to press new project, and this little window pops up, and right away it's giving me an error. It's saying, well, it's trying to save into my documents folder in my user folder on my computer's C drive in Windows, and that's an okay place to save. But when you make a new Godot project, it needs to be in its own empty folder. And my documents folder is definitely not empty. And so that's a problem. So what I'm going to do is I'm actually going to make my project have a name, and at the same time I'm going to create a new empty folder on my computer with that project name. When you make a new Godot project, it has to have its own new empty folder with a name that you want to use. So I'm going to go ahead and press browse, and I don't want to save in my documents folder. I'm going to save onto my desktop so you can see it. So I'm going to navigate to my desktop, which is normally a folder in your user folder. If you're on Windows or Mac. Mine is actually on a different drive. It's on my E drive, and there's my desktop folder, and there's that Godot version 3.1 program that's right here on my desktop. So I'm going to say select current folder. This is my desktop, and I'm going to create a new folder for my project. So I'm going to call this Godot basic move and dodge game, and that's going to be the name of my project and my project folder. I'll just make that a capital letter and press create folder, and as you can see, it added that folder name to my project path. It actually made that folder on my desktop, and now I don't have that error anymore. We're good to go. I'm going to press create and edit. Just a note here that if you want to turn down the quality of your game to support older computers or older cell phones, if you're exporting to an older Android or iPhone device, you might want to select OpenGL ES2. In my case, this is going to be a computer game, and so I'm just going to support OpenGL ES3. So let's go ahead and open Godot's editor. This is the Godot editor, and it's a pretty intimidating interface, so let's go ahead and break it down. The main part of the interface in the middle with your 3D scene is called the main workspace area. Along the top bar of Godot, there are 4 switch buttons for this main workspace area. The default is this 3D workspace, but if you're making a two-dimensional 2D game like a platformer, or you're making even a flat 2D menu for your game, or a heads-up display like a little coin counter, well, you're going to use the 2D workspace, and as you can see when you switch over, it looks entirely different, and it has a set of outlines. Hopefully you can see these on YouTube. They're purpley, blue, aqua, and pinky looking outlines, and these describe or show you the size of your current viewport that you'll actually see your game in. Next up, of course, we have the 3D viewport, and after that is the scripting workspace. This is where you're going to do all of your coding, adding scripts using Godot's, in this series anyways, using Godot's native language GD script. This is where you program objects to have behaviors. We're going to deep dive into this in the next video. Also, under the script workspace, this is where you can look up online documentation of everything in the GD script language. If you're not sure how to make a character move, you can look it up in the online docs, and there's actually excellent features that help you get directly from your code into the online docs, so you can look up the code that's relevant to what you're doing and then go back quickly into your own code. Last up is the asset library workspace. This is Godot's online repository of things like example projects and image textures like sprites, 3D models, materials for 3D objects. We're not going to get into here. In fact, I haven't explored this very much because, again, I'm going to be giving you everything you need in the links below these videos on YouTube in the description area. On the left, on the bottom, and on the right are panels. They're called docks in Godot, and on the left-hand side at the top is a dock called scene. This is probably the most important panel or dock in Godot. This is where you create what are called nodes that are the building blocks of your scene. This ends up looking like a list of everything that's in your game scene, like characters and sprites and lights and cameras and meshes. This is a lot like Blender's outliner window that you would find at the top right of Blender's interface, but you end up spending a lot more time here because you actually make new objects over here in this side panel dock. Below that is the import dock. This is where you can change import settings, specific settings for an object that you have selected in your game in case it didn't import right, or you want to change the import settings of that object. This could be like for a sprite or an image texture that you're bringing into a game. You might want to change the filter on that image, or you might want to change how Godot treats a 3D mesh object as it imports it into Godot from, let's say, a program like Blender. You might want to tweak a few of the settings when you're bringing in other files. Below that is the file system dock, and this is basically a list of all the files and folders that you have in your game folder on your computer. Your game folder has a special name in the editor. It's called res. So if you're ever programming and you need to reference another file in your game project folder, like an image texture or a 3D model, you would probably point to it by saying, hey, look in res, kind of like a website address like http://, but it's res:// and you can see a list of folders and files like image textures or scenes or things like that all listed here. On the bottom of your main workspace is a panel that has lots of different areas to it, things like output, debugger, audio, animation. Whenever you need to edit some of the main aspects like animations in your game or tweak the audio in your game, you'll do it down at the bottom. We can't see anything there. We'll get to those later, but just know that there will be bottom panels at some times when you're creating your game. Lastly, on the right side, we have a few docks. We have another really important one. It's called the inspector. If you have an object selected in your game, or really anything like a node, like something that actually adds something that you can't see, like sound or music in your game, if you select it, you can see all of its properties on the right hand side in this inspector dock panel. For instance, if you have an image sprite in your game, like an image file, well, if you want to change the size of the image, like its dimensions or its rotation, or even what image file it should display, its properties will be over here. Behind this inspector dock is the node dock, and basically this is where you'll be able to allow objects to communicate with one another using what are called signals. We're going to get into signals when we get into programming in the upcoming videos in this mini-series, so don't worry about it, but also know that you can add objects to groups in this node panel, so don't forget that this node dock is here. Let's take a few moments to look at Godot's 3D viewport in the 3D workspace. If you're familiar with Blender, you'll be right at home here because many of the controls in the Godot 3D viewport are the same controls that you would use in Blender's 3D viewport as well. If your computer has a mouse with a mouse scroll wheel, you can scroll up and down with your mouse in this viewport area, and that will zoom the scene in and out, usually to the middle of the scene where the three axes meet. So scrolling up zooms in, scrolling down usually zooms out. If you hold your mouse wheel down like a button and then move your mouse around, you can see that this is what's called orbiting. Orbiting is like rotating your view around in the 3D scene, usually around the middle of your scene where the three axes meet. If you're orbiting and you move your mouse up while holding that middle mouse wheel button down, you can look at your scene from the bottom. Likewise, if you move your mouse down, you can see your scene from the top. And of course, you can spin your view around from any direction that you like. If you want to see what's to the left and right and above and below your current viewport, you can hold the Shift key down on your keyboard and then orbit. So Shift and middle mouse wheel press down like a button, and you can move your mouse. And this is kind of like strafing. If you're used to playing 3D first-person shooters, looking left or stepping left and stepping right, it's called strafing, but it's called panning in Godot. You can also hold Shift and pan up and pan down as well. And unlike Blender, if you hold your right mouse button down and move your mouse around, this lets you look around in your 3D scene. Okay, so this is the look around kind of controls for your scene, so you don't have to actually move your view to see behind you. You can do that very easily. And if you're looking around by holding your mouse right button down, you can also press the W key, and this will enable fly through mode. So I'm pressing the W key while holding the right mouse button down on my mouse, and I believe if you hold S you can go backwards. Of course the controls for that are a little bit weird. And if you press D you can move right, A you can move left, and Q will go down and E will go up. Also in this 3D viewport, you have this top left menu. I'm going to orbit around so I can see the middle of my scene again. You have this top left menu, which lets you change your current view. If you want to see your scene from the top, well, you can just select top. If you want to see your scene from the right, you can do that. If you want to switch between perspective modes and what they call orthogonal view modes in Godot, you can do that. And if you're not familiar with what this is, perspective, which is the default, lets you see a scene kind of naturally. In a perspective view, if you have an object and it's farther away, it will appear smaller than if it's close to you, which is how things work in the real world. If you want to see your game that's 3D but look more flat, you can change this to orthogonal view, and as you can see it's still 3D but it looks flat, and again objects that are farther away or near will not change in size. But let's go ahead and change it back to perspective. If you have an extended keyboard on your computer, like a keyboard with one of those side number pads, you can use those number keys, but not the top row of number keys. You can use the side numpad number keys to switch between these views really easily. If you press the 1 key on your number pad, it will go to your front view. If you press 3, you'll go to the right view. If you press 7, you'll go to the top view. And if you press the 5 key in the middle of your numpad, it'll toggle between orthogonal view, which is the flat view, and perspective view. So if you're like this in perspective, you can hit 5 and it'll go into orthographic, and then back and forth. Lastly, you can split your 3D viewport up into different separate viewports. If you want to split this viewport into 2 separate 3D viewports, you can go up to View and change it either to left and right 2 viewports like that, and you can orbit each one and zoom each one independently. You can also have 2 viewports that are up and down, divided like this. This is especially handy if you want to see through your scene's camera in one viewport and then edit the scene in the other viewport. You can also have 4 at the same time or 3 at the same time, but typically we just have 1 or 2, one for the scene and one through the camera, which we don't have in our scene yet. Let's go back to 1. Okay, let's go ahead and start actually building our game level in the 3D workspace viewport area. But actually, when you build objects or add objects into your game, you're not doing it in this viewport area. You're first adding it over here in your scene dock panel area. This scene dock area is where you add what are called nodes, which are Godot's building blocks for a game. There are a few shortcuts that Godot 3.1 has added to get you started, but if you press this little plus button in the scene tab area, you can see it brings up a create new node dialog box, which has a list, which is really this kind of a list where you have collapsible sections and then categories. This is called a tree. And in this tree, you're going to find categories of different kinds of nodes, and you might recognize some things that might be handy for you to have in a game. Nodes are like little building blocks that you have to combine together to make parts or even an entire game. So some objects in your game might need to be animated. So those parts of your game or objects might need to have an animation player node as part of them. You might need to have an object tween, in other words, animate back and forth in a level, so you might have a tween. Or they might need a timer to know when to do things. Or they might have a skeleton like an armature rig. Or maybe you need to have 3D objects, and that's in a category called spatial. And in spatial, you might have a camera to add to your game. If you want objects to bump into each other, you'll probably need a collision shape. If you want to have three-dimensional objects that behave according to physics, well, there are what are called physics bodies, kinematic bodies, bones, rigid bodies, static bodies. If you want to bring a 3D model in from a 3D modeling program like Blender, you'll need to add what's called a mesh instance. And that's under visual instance and then geometry instance, and mesh instance is right here. So all of these nodes, when you combine them together in the right way, they are the building blocks of a Godot game scene. Now, when you make a Godot scene, I'm going to close this panel for now. When you make a Godot scene, it needs to have one root node, and they already give you shortcuts to add one of these nodes to start off your scene. So I'm going to press 3D scene, and what this is going to do is this is going to add a node that I could have added through this little plus button. It's called the spatial node, and that's a good node to start off your entire tree. In other words, this kind of structure with collapsible categories that will make up your overall scene. So I'm going to press 3D scene, and if you're following along, so can you. And when it added that spatial node, of course it adds it into this area, but it also gives us a 3D gizmo, handles where we can rotate this spatial node, this 3D object that has nothing in it, but it's required. We can move it around, we can rotate it. And if I use one of these top tools, I could probably even scale it, but you know what? You actually do not want to do that for this spatial node. So I'm going to press Control Z a few times on my keyboard until it goes back to the middle. We're just going to leave it put. Now this spatial node is going to be the root node of our scene. So I'm actually going to name it right away. I'm going to call it level. So I'm going to double click on its name. I'm going to type in L-E-V-E-L with a capital L at the beginning. And everything that we add to our game, all the main objects, are going to be children. In other words, subcategories or underneath and indented below this main level root node. The first object I'm actually going to add to my game is a three-dimensional box, in other words, a cube. And this isn't going to just be a cube that sits there static in space. It's going to be a cube that actually behaves in the way that a box would behave if it was in an environment with gravity. So we're going to add a physics object to our game. Now when you add objects into a 3D game, they're not just going to be made up usually of one node. If you think about a 3D object like a box, it has to have a 3D mesh object, in other words polygons that you can see. But just because you have polygons doesn't mean that they actually behave in a way that relates to physics. So it turns out that you need to have another node object that is linked to it that is called a collision shape. And both of those things need to be part of what's called a rigid body object in Godot. So we're going to add that one first. You're going to see exactly what I mean. I'm going to press plus. And I can actually navigate my way to find a spatial, and you don't have to follow along with me here, a spatial, and then collision object, and then physics body, and then a rigid body, and that even has a few, or at least one subcategory called vehicle body. But if you don't want to find and navigate this tree, you can just type in the search bar rigid, and it'll narrow down your search. Now I need you to know that the blue icons here are all 2D versions of the same nodes. We're not going to be using those until later in this series. So we're going to select rigid body, the one with the little pinky red icon, and double click on it. Just like that. Now when we added it to our scene, we actually can't see it because it has nothing to see, but it did become a child of our level. It's a child, and I know that because it has this line and it's indented. It's more farther away from the left-hand side of this panel as opposed to level, and if I collapse my level, it hides all of its children. So that's the way that it should look. Now this rigid body, I'm going to double click on its name and type in box. That's what it's going to be called. And it has this little warning error message. Yes, something is wrong. Let's go ahead and see what that says. It says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape or collision polygon as a child to define its shape. Well, what does that mean? Well, it's saying that a rigid body is great, and you need to have it in order to have a physics object that will tumble and fall with gravity in your scene, but it doesn't know enough about itself. in order to really interact with other objects, like bump against other things, it needs to have a collision shape. So I'm going to select that box, and we're going to give it a child. This is called a tree, and branches of that tree. This box will be its own branch with its own children. So I'm going to press this little plus with box selected, and I'm going to search for, and again, if you don't want to search and you want to find things yourself, I'm going to search for spatial, and I will need a collision object. And actually, it's not under there. It's just called collision shape right there. If you don't want to find it in this tree, you can just type collision, and that will help you find it. Collision shape is right there. I'm going to double click on it to add it, and it added it as a child of the box rigid body object. Now, if you didn't do it right, and if you had your level selected when you added the collision shape, well, it might look something like this. Both of these are now even. They're both direct children of your level, and that's not right, and you get errors on both of them. If you want to refix the parenting here, I'm going to drag the icon of this collision shape onto the box, and that will make it a child of box. And now you can see it's indented more from the left side of the screen, and the box will collapse the collision shape into it when we collapse it like that. So that's great. This box now has a collision shape, and it has an error. I'm going to click on that error and see what it says. It says a shape must be provided for collision shape to function. Please create a shape resource for it. Oh boy, it's actually not as scary as it sounds, and this is a perfect time to introduce and look at the inspector dock panel on the right side of the screen. I'm going to press OK, and I'm going to select my collision shape and look over here on the right side of my screen at the inspector dock panel. This collision shape object needs to know what shape it should be. Should it be a cube? Should it be a cylinder? Should it be a cone? Should it be a sphere? It doesn't know. You have to tell it, and that is called a property. It's under the inspector tab. This is that dock, the inspector. So next to shape, look what it's saying with my collision shape selected. It's empty. It doesn't know what shape to use. So I can just make a new or select a new resource shape for this. I can press this little down arrow and choose a new box shape. You can see what other basic primitive shapes, 3D shapes there are from this list. I'm going to select a new box shape, and as you can see, we now can see the size of our box on the screen. We're not going to touch it or move it at all, please, because we're about to give this object a mesh, and you'll see why we don't want to play with this at all until we add that mesh. So let's go ahead and do that. Our box over here in the scene panel has one child, a collision shape node, and so I'm going to select the box again. That box needs a mesh, so I'm going to select it and press plus. And I'm going to delete my search so we can find it ourselves. Under node and spatial and visual instance, there's a section called geometry instance, and here if I expand that out, we can find mesh instance. Don't get confused if we open that up. There's soft body, and there's also one called CGI mesh somewhere. If I just search for mesh, you can see that there's one called, pardon me, CSG mesh. We're not going to use that one. The one that we want is called mesh instance. So I'm going to go ahead and double click on mesh instance to add it into my scene. And if you did it right, this mesh instance will be a child of the box. The box will have both a collision shape and its own mesh. Now the mesh, we can't actually see it because it doesn't know what mesh object, what polygons to actually use. Later on in this mini-series, we'll be actually taking a model that we have in Blender, and we'll be exporting it from Blender into a file format of 3D model that Godot can understand, and then importing that model into Godot to use for different objects in our game. But for now, this mesh instance node with it selected over here in the scene dock, if I then go over to the inspector with the mesh selected, we can see this mesh is empty. It doesn't know what mesh to use, and Godot actually has some primitive meshes built in. If I click next to empty, you can see it can add a new cube mesh, cylinder mesh, plane mesh, sphere mesh. We're going to add a new cube mesh. And as you can see, it adds a cube into this little mesh area right here. We can see it, but we can also see it in our 3D viewport. And if I orbit around, yeah, it's a full cube, and we are good to go. Now, let's jump back and take a look at that collision shape for a moment, because we might want to adjust where this object collides with other objects. If I select this collision shape node in my scene dock, you can see we have these little pink dots, and these represent the sides, or what are called the extents, how far this primitive mesh extends. That's why it's called the extents of the collision shape where they are. So if I grab this little pink dot at the top and drag it up, you can see that my collision shape, in other words the force field where it hits other objects in the scene, is now bigger than the visual mesh that we can see. And if I play my game, this cube will actually hit other objects, not on its own mesh, but where this larger bounding box is of the collision shape. If I do this and this, it won't really make sense in my game for my player, because the box will hit other boxes or other things before they actually see it hit the box. So it's important to know how big your collision shape is as opposed to the actual mesh itself. This collision shape, if I select it, I can reset these extent values. If I select the collision shape over here, and then in the inspector, I can actually expand out this box. So, not using the little arrow, but just clicking on it itself will expand or contract that area. You can see the extents are 2.639 and other long number values. If I change those back to 1, I believe, and 1, and press tab and press 1 and press enter, or just reset those all to 1, you can see it's now at the right size. If I make them too small, again, the cube will end up going into other objects, at least visually. Okay, so now we have some objects, or at least one object, using multiple nodes in our scene. So I'm going to go ahead and try to see if I can run this scene and play my actual game, or at least see our game scene. So I'm going to go up to the top right of my top bar in the editor, and I'm not going to press this play button because that will play my entire game, and that actually requires that I tell my game project what the first scene in my game is. And typically your first scene in your game is a loading screen or your title menu of your game. We don't have those yet, so I'm not going to press this play button. Instead, I'm just going to press the play scene button, which is this one, which will play the scene that I have open right now. So play scene, and it tells me this scene has never been saved. Save before running, yes. So I'm going to do that. Yes, save, and it saves it into my project folder called res in the editor, and it will give it a name of level.tscn. A tscn file is a Godot scene, and I named my first root node level, so that's good. I like that. I'm going to press save, and it'll save, and it'll launch my game, and this is my game. We can't see it, and that's because our scene doesn't have a camera. A 3D scene needs a camera in it. So let's close that game preview window and add a camera to our level. In order to add a camera, we have to make sure we add it to our main level, which is called level. We can't add a camera as a child of the box. Well, we could, but we don't want to. So I'm going to select level, and I'm going to press plus, and I'm going to delete my search. You'll notice also that if you have previously used nodes, they'll be down here. So this is handy if you want to add more rigid bodies. You don't have to find them or search for them. You can just click down here to add them. A 3D camera, everything 3D is under spatial, and it's called camera right there. There are subcategories, but we can just add the normal camera, or you can just search for camera and add the pink one, not the blue one. Okay, that's for 3D. When we add a camera to our scene, again, it should be a child of the level and not a child of the box. So if it is, you can drag it onto level. And if I select it over here, I'll need to move it using this gizmo controller here. And if I pull it back on the blue Z axis, you'll see that it looks like this. It's pointing in this direction, and I can move it up. In fact, if you're used to Blender, you'll notice that in Godot, the axes are a little bit funny. The Z axis is actually your forward and back axis, and your Y axis is up and down. It's opposite in Blender. X, the red axis, this is the Cartesian plane, X, Y stuff that you would have learned in middle school math class. The Y axis is up and down in Godot, whereas the Z axis is up and down in Blender. A little bit different, but it's not anything you need to worry about. Just know that Y is up and down. If I pull this camera back, And then I go with the camera selected. I can actually preview the camera. That's what we have right now. Maybe I'll unpreview it by unchecking that box, pulling it back some more, and then I might pull it up a little bit. And then if I grab this little hula hoop, I can rotate it on the x-axis to point it down. There are also in Godot individual move, rotate, and scale gizmo tools, and you can get to those, I believe, with the QWERTY keys on your keyboard. If you press Q, it'll bring you the multi-select tool. It also has move and rotate. W will bring up your move tool only. E will bring up rotate. R will bring up scale, and then there's a few more that we'll get to in future videos. So I'm going to move my camera back, and let's see what it looks like. I might rotate it more pointing down, and let's go ahead and see what our game looks like when I press play scene. And our box falls because it's actually a rigid body, which is a physics body. I'll do that again. I'll close that and press play scene. Our cube is there, we can see it, and it's falling down. That's great. Let's go ahead and add one more object, and then we'll play around with this physics scene. We're going to add a floor. And so what I'm going to do is actually select my entire box by clicking on it over here. And I'm going to use my move tool, and I'm going to move the box up. It's important that you don't move things individually, components like the collision shape. If you move it up, well, that means that it's going to collide with in different spots or with different sides than the actual mesh. So when you want to move an object, select its most parent object itself, the box, in the scene panel, and then you can drag it up. I'm going to add a floor to the middle of my scene, so I'm going to select my main scene, call it level. I'm going to press plus. We're going to add a physics object, but this time it's not going to be a rigid body. It's going to be under spatial and visual, pardon me, not visual, it's going to be under collision object and physics body. If we want an object to be in our scene that's 3D, but we don't want it to move or fall with gravity, but we need it to collide with other objects, that's called a static body. Static means not moving. So I'm going to select static body and double click, and it added it to my scene, and it's a child directly of our level. It's giving me an error. Let's see what that is. It says, this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape or collision polygon as a child to define its shape. We've seen this before. It needs a collision shape to know where its bounds are, where its force fields are that it'll hit other objects at. So I'm going to select this static body. I'll name it, double click to name it floor. And with it selected, I'm going to press plus. I'm going to add a collision shape, the same thing that we've already added to our box, the rigid body. And so if I double click on collision shape, it'll add it as a child of my floor. And it has a problem. Its little error says that it doesn't know what shape it's supposed to be. And that's over again, and hopefully you're seeing this pattern here. That's again, I have to select it and then look at its inspector, its properties, and I'm going to give it a shape. I'm going to make my floor, I'm going to make it another box actually. So I'm going to change it right there, and it looks like that. Now I'm going to change its extents in a moment after I add its mesh. You might be tempted to use not a box, to use a plane instead, but actually if you add a plane, it might give you a message. Yes, it is. It's giving me a little error over here saying plane shapes don't work well and will be removed in future versions of Godot. Please don't use them. So they're being deprecated. They don't want you to use them anymore because they don't work well. So we're not going to use plane shapes. We're going to use a box shape. Okay. Our floor also needs a mesh so we can see it. So I'm going to add another cube. I'll select my floor. We can press the plus to add a mesh instance, which we have in our recently used node, so I'll just add it that way, or search for mesh and mesh instance, not CGS mesh, that one we don't want to use. And this mesh instance doesn't know what mesh or what polygons to use, so I'm going to select with it selected in the scene doc. I'm going to select its mesh in the inspector. We're going to use a cube. Now if you have a cube mesh or any mesh and you click on its little icon, it will expand out the properties of that mesh and this is where you can change its size. So I'm going to keep its size. And remember that Y is up and down. We're going to leave it at 2 in dimension up and down. I don't mind having a thick floor, but I will need to change its size on the X and Y axes. So I'm going to change it. I can actually click in there and type. Let's say I want to be 30. So I'll press enter, and that's going to be the size of my floor on the X axis. I'm going to leave Y, its height, at 2, and I'm going to change its Z to 30 as well. So we've got a nice big floor to work with. This will not work yet until I change my collision bounds. So I'm going to go back over to my floor and select its collision shape, that first node that we added to it. And you can see that if I zoom in, it might be quite hard to see. So I'm going to hide my mesh for a moment so you can see it. The force field where this static body will know to hit other things is really small. It needs to be bigger side to side and front and back. So I can drag these manually. I can also, if I show my, actually I won't quite show my mesh again. If I have my collision shape node selected over here, I can go into its box shape in the inspector, and I can expand it out just by clicking on its name, and I can type in the values that I want. Now, extent values are a little bit different than overall dimension or size values. Our size of our floor is 30 by 30 by 2, but the extents of a collision shape, I'm going to hide the mesh again, are away from its middle. So if you want to have it have an overall height of 2, then the y-axis extents should be 1, because it's 1 from the middle up and 1 from the middle down. Same thing for x and z. We want to have 15 and 15 and 1 for y, obviously. So 15, 1, 15 will mean it's actually 30 across, 30 front and back, and 2 up and down. So if I go and show my mesh instance now, you can see that it's exactly the same size. Okay, I think we're good to go. I could even move my floor down to meet my grid. So I'm going to select my floor in the scene panel, and I can move it down using the move tool. If I hold the control key or the command key, I believe on a Mac, while I drag, it'll snap to even increments, the same increments that are the units on the grid floor. So if I just hold control or command on a Mac and left click and drag down, it'll snap down to meet the surface of the floor. Okay, let's go and see what this looks like. I'm going to play my scene. When I play scene, I believe it'll automatically save. There's a little star here, which means that this scene is not saved. Yeah, it's saved. And we can see our box fall, and it hits the floor. The reason why everything is a little bit blue is because the sky, the environment in our scene, is blue, and we'll talk about how to change that in a future video. Let's do one more fun thing before the end of this video. Let's rotate this cube and see how it tumbles, and let's add more duplicate cubes. So I'm going to select my box, and I'm going to use the rotate tool. And in fact, I'll just use the selection tool. That's the Q key on my keyboard. And I'm going to rotate it in a funny way, so that hopefully a corner hits the ground. And let's try playing this scene. And as you can see, it tumbles like a normal cube would. And if I go into my scene panel, I can right click on my box and I can say duplicate. And now I've got box and box 2. I can rename box to box 1. And I'll select box 2 and move it straight up. Maybe I'll rotate it a little bit differently. And I'd be able to duplicate one more time, right click, duplicate, and I'll move this one up and rotate it differently. And let's see what this looks like through my camera. 3, 2, 1, play scene. And now we've got a physics scene that acts fairly realistically. So that will be it for this first video on creating a basic move and dodge game in the Godot Game Engine. In the next video, we're going to start making a character and programming using GDScript, and we're going to make our character be able to move left, right, forward, and back when you press the WASD or the arrow keys on your keyboard. That will be it for this video. Thanks for watching. If you like this video, of course, click that like button below this video. And if you want to see more videos like this one in Godot or in Blender, click on that subscribe button below as well. Check out my Facebook page at facebook.com/borncg. On that page, I post previews and sneak peeks and surveys about what I'm working on next. Thanks for watching. See you in the next one. Bye-bye.